Hey guys, it's me. We're going to go through topic 6. I have 20 minutes before I need to leave for yoga, so it has to be done before that. In this one we're going to talk about sig figs, moles, empirical formulas, limiting reactant. I'm hoping I have enough battery also. Alright, let's get started. Okay, first topic is significant figures. So, significant figures, the reason why we have them is because they're used in measurements to account for inaccuracies that exist. So, our measuring tools all have some source of error in them, so that's why we need to include them in our measurements. On the AP exam, as a general rule, if they ask for sig figs, you don't know how to do it, go with 3, because they give plus or minus 1 sig fig as leeway. Alright, so in my class I did the Atlantic Pacific rule. Atlantic Pacific, and this is a decimal point. Okay, if decimal point is present, start counting left to right. Don't start counting until you reach your first non-zero number. Once you start counting, don't stop counting. So for example, 0.012. These zeros don't count. 1, 2. 2 sig figs. Okay, if you had 0.0120, those zeros don't count. Once you start counting, 1, 2, 3, don't stop. Okay, absent, we're going to go in this direction. So if your decimal point is absent, start counting on the right to the left. Don't start counting until you hit your first non-zero number. Once you start counting, don't stop counting. Alright, so for example, if we have 1020, don't start counting until your first non-zero, which is 2. 1, 2, 3. Okay. I think that's just about all you need to know about that. Okay, so adding and subtracting with sig figs. So if you're doing calculations where you're adding or subtracting with measurements, you need to account for your sig figs. Your answer needs to be rounded to the least number of decimal places. So for example, if we're adding 5.25 plus 2.5, your answer looks like it's going to be 7.75. You need to round to the least number of decimal places. This has 2 decimal places, one decimal place, chop it off. Because there's a 5, round up, so 7.8. Okay, multiplying and dividing sig figs, once the number is calculated, round to the least number of significant figures. So let's see, we'll do 2.3 times, let's just say 4. Okay, 12, carry the 1, 8, 9, 9.2. Alright, 2 sig figs, 1 sig fig. Your final answer can only have 1, so go in this direction. Chop it off there, your answer is 9. If you had something like 39 and you need to round to 1 sig fig, it looks like it would be just 4, but you're going to use a 0 as a placeholder, so that would go to 40. Okay, mole conversions. You have moles A to moles B. This is used with the ratio of your coefficients. You have grams, liters of a gas at STP only, to particles. Grams, liters of a gas, particles. You can also do liters of a solution. And this is the one where you guys didn't like it very much. Okay, so going from grams to moles, you're going to need to know the molecular mass. Liters to moles, 22.4 liters. Particles to moles is your Avogadro's number, 6.02 times 10 to the 23rd. Liters of solution, you're going to use molarity, which is your mole per liter. Okay. empirical formulas. Given percents or grams, you're going to convert to moles. Divide moles by the smallest number. This is going to give you the subscript of atoms. If you get decimals that are greater than 0.1 away, you want to multiply that number by a number that's going to give you a whole number. So if you have 1.5, obviously you're going to multiply each thing by 2. Oh, this should say ask. Okay. Alright, that was good. Let's do a problem. Okay. A hydrocarbon contains only C, H, and O. Complete combustion of a 0.255 gram sample produces 0.561 grams carbon dioxide and 0.306 grams H2O. Find the molecular formula if the molecular mass is 120. So, what we know is that you have a combustion reaction. Ooh, not plus CO2. Plus O2 yields CO2 plus water. And they give you the mass of your sample, and they give you mass of your carbon, 0.561, and your water. Okay, carbon dioxide, not carbon. Okay, so this carbon, the only place it came from is from here. So we can convert grams of carbon dioxide into grams of carbon. Okay, so 44 grams, 1 mole, 1 CO2. Don't forget to write the step, 1 C. 1 C weighs 12 grams. That gives us 0.153 grams carbon. Okay, same thing with H2O. I'm getting a low battery sign, so we'll see. Alright, we have 0.306 grams H2O, 1 over 18 grams, 2 H's for 1 H2O, crisscross, 1 H weighs 1 gram, and I'm getting 0.034 grams of hydrogen. So they tell you also the mass of the sample. So you know the mass of the sample is 0.255 grams. So C, H, and O. So subtract 0.153 grams C and 0.034 grams H, and that's going to give you your amount of O you have left over. So 0.068 grams O. Great. Okay, so from there, the next step is to convert to moles and divide by the smallest number. So we have 0.153 grams C. Convert to moles, you get 0.01275. You have 0.034 grams H, which you know is going to just give you 0.034 moles H. And then we have 0.068 grams O. 1 over 16 gives you 0.00425 O. Divide by the smallest number, which happens to be your O's. So divide all those, you end up with 3 C's, 8 H's, 1 O. C, 3, H, 8, O. Okay, so they ask you about molecular formula and they give you molecular mass. So what we just solved was the empirical formula. You need to look up how much this weighs. So C3, so 12 times 3 is what? 36 plus 8, 44 plus 16 gives you 60 grams. Okay, so if the real molecular mass is 120 grams, you're going to divide it by your empirical mass, 60, and 2 gives you your X factor, or the multiplier. So all you're going to do now is just take the 2, multiply across. You get C6H16O2. Sorry I'm going fast. I kind of want the battery not to die. Okay, moving on, limiting reactant. I'm not going to read all that with you. I'm just going to do the problem. Okay, in one experiment you have 0.3 0.36 moles of PCl5 added to 2.88 moles of water. What's the theoretical yield of HCl? So a couple things. When they give you two initial values, it's always a limiting reactant. If they say it or if they don't say it. Okay, so to start, we're going to take 0.36 moles of PCl5. You're going to convert it to moles of the other reactant. So 1 PCl5, 4 H2O, and that gives you 1.44 mole H2O needed. Okay, same thing with this one. 2.88 mole water. There are 4 waters, 1 PCl5. That gives you 0.72 mole PCl5 needed. Okay, now you want to ask yourself, do I have enough? I need 1.44 moles. My problem says I have 2.88 moles of water. Do I have enough? Yes. If you have enough, that's your excess. The other one, 0.72 moles of PCl5 are needed. We're only given 0.36, so do you have enough? No. So PCl5 is your limiting. Okay, so if you get both of them that are okay, then something happened. So now to find the theoretical yield in moles of HCl, you start with your limiting reactant and you start with the amount that's given in the problem. So 0.36 mole PCl5, 1 PCl5, and we're looking for HCl. So we go 5 HCl. That gives me 1.8 moles of HCl. Okay, so then in this problem they say in an experiment 1.4 moles of HCl is collected, what's percent yield? So percent yield is the opposite of percent error. It's actual yield over theoretical yield times 100. So actual is the number they will always give you. So 1.4 over theoretical, what you just solved for, 1.8 times 100. I didn't do that ahead of time. So that's the setup. That's what you would do. Another possible question is how much excess reactant is left over. So that's back up here. If you know you need 1.44 moles and you are given 2.88 moles, you just subtract, which I think is just going to give you 1.44. Okay, that was fast. Hopefully that was helpful. Bye-bye.